So detection engineering for OT and industrial environments, where do you start? For one, you want to start with what protocols and what areas do you need to care about. The protocols you care about will inform what's possible from a detection engineering approach. And what I mean by that is what is inside that protocol, how does that protocol need to be handled? Is it a protocol that's known? Do you have to reverse engineer? Once you understand the core part of the protocol, then it moves into questions of what data can you actually get through? What function codes does that protocol have? What is that protocol used for? Is it just used for communication of operational values, or is it used for program uploads, for firmware updates, for other things like that? With that data, knowing what a protocol is capable of, you then have to look at what devices is it used on. Is it only used for PLCs? Is it only used for certain devices? This matters because then the behavior of where that protocol is used is also going to drive, the scenarios you need to deal with detection engineering. Finally, you need to think about what MITRE attack and ICS attack techniques you need to worry about, right? Again, you can build that map to say, hey, this protocol is capable of, again, this firmware upload, this ladder logic update, this other thing. And then like, hey, when I'm writing rules for this, when I'm working through this protocol, these are the things I need to hit. Similarly, knowing what it's used for, if it's used for certain core values or used for configuration updates, that's what's going to drive a lot of the rules that you develop when you're dealing with these protocols. So where you start with OT detection engineering, it starts with the protocols, it starts with the technologies, understanding what they are, where you'll see them, what they do, and that builds a context to write rules that ultimately then can be paired to the reality of your environment.